Hello, this is Zachary Fisher, and this video will demonstrate some of the custom mechanics that I've created for my level Asylum Escape. The first mechanic that I'd like to show off is the static cameras or the CCTV cameras that I've created. These cameras have a trigger that tells when the player enters and tells the player which camera they are currently using. You can see as we walk around the level, enter new areas, the camera will change depending on what area the player is in. The CCTV camera actor itself is a trigger volume and a camera component. When the player enters the overlap volume, we set the current camera of the player to the camera that they've overlapped with. The tick event here just simply calculates the lookout rotation for the camera so that it is always pointed at the player as they move through the world. On the CCTV player controller, we check to see if there is a current camera, meaning they have previously transitioned from a camera to another camera. We get the rotation of that camera and save that for later. We turn the tick off, and then also save the X and Y values of the movement input. This is where we change the view target to be the new camera, and we start ticking the new camera so that it'll start facing towards the player. As the camera is not attached to the player and is statically set in the world, we have to take its rotation into account when we calculate the movement for the player. Here we are checking to see if we have a valid rotator for the old camera. This just checks it against some junk value that you would never get normally to see if we have some actual data set here. If we do have an old rotator value, we're going to continue using that when we calculate the movement for the player. Otherwise, we are going to use the new camera's movement. During testing, it was found that when the camera was moving from one camera to another camera facing the opposite direction, the player would immediately turn around and move back the opposite direction. This was because if the player was holding the forward key, they transitioned to the new camera, the new rotation would tell them that forward is in the opposite direction they were traveling. To account for this, it was decided that the old camera's rotation should be used for a short time when transitioning from camera to camera. The tick event here listens to see if the current move components are equal to the previously held key. If either one is not currently the same, we're going to set the old camera rotator to that junk value, which should then force the movement to start accounting for the new camera's rotation instead of using the old camera's rotation. This allows the player to continue holding forward when moving from camera to camera, and it'll save that forward movement until the player appreciably changes the directions that they are holding on the keyboard. The next mechanic that I'd like to showcase is the NPC that wanders the bowels of the asylum. The NPC is driven by a state machine. Each state dictates what actions it should take at what time. By default, the NPC will navigate to waypoints that are placed on the map. This is called the patrol state. On reaching one of these waypoints, they will enter the idle state, where they will idle for a random amount of time before transitioning back to the patrol state and moving to the next waypoint. If at any point the NPC sees the player, they will begin actively pursuing the player until they either catch the player or the player has left their line of sight for long enough. If the player is able to evade the NPC for long enough, they will switch back to the patrolling state and continue the cycle of patrolling and idling. If we jump into the event graph, we can take a look at the states themselves. Every state is a child blueprint of the state base class. This means that each state will have an event for entering the state, exiting the state, as well as ticking the state, beginning overlap and ending overlap. On entering the patrol state, the NPC's speed will be set to its patrol speed, which should be less than the speed at which it chases the player, and it'll move to the next waypoint in its array. All waypoints on the map are stored in this waypoint array, and the currently selected index of that array is also set in a variable. Upon overlapping with the current nav point, it will choose the next nav point in the array and change to the idle state. Entering the idle state, the NPC's movement is stopped, and a random amount of time is set for it to idle. Every tick, we check to see if this time has elapsed, and if it has, we change back to the patrol state. The NPC's sight is driven by the AI perception component. When the NPC sees the player and the player is not invisible, we set the current target of the pursue state to the actor. We change into the pursue state. If at any point the NPC is not able to see the player, we set a timer to tell when the NPC has lost sight. When this timer has elapsed, the NPC resets back to the idle state, resetting the loop of idling and patrolling. On entering the pursue state, the NPC's speed is set to a higher speed, and it plays a sound to alert the player that they have been seen. Every tick while in this state, the NPC will try and navigate to the current target, which is the player. At any point during this state, if the NPC begins overlapping with the player, we apply damage to the player, we change its state back to the idle state, and play a sound letting the player know that they've been hit.